Hey everybody, it's Mr. Cassandra here. You just watched a short video explaining the rules. Now we're going to do the example problems. Now I am doing the example problems from the online textbook, page 438. I'm going to do the odd numbered problems. You will be doing the even numbered problems. And every even number problem that follows an odd number problem is done exactly the same way as the ones I'm doing right here. So there's no excuses. If you watch these and model after these problems, then you can do the other ones. And if you have any questions, please private message me. So here we go. Number 3 is an example of multiplying two exponents that have the same base. When you multiply the same base, you add the exponents. So that would be 4 to the 8th power, which is 4 to the 2 plus 6, right? All right, number 5, same rule, but this has no exponent. Well, when it has no exponent, we put a 1 there, because 3 with no exponent is 3 to the 1st power, which is a 3 one time. So now all I'm going to do is use my rule, same base, add the exponents, and I get 3 to the 4th power. Okay, number 7. What if it's a negative number raised to a power? Well, as long as they're exactly the same base, which these are both negative 7, raised to the 4th power and raised to the 5th power, I just add the exponents, so it's negative 7 to the 9th power. The parentheses are very important because negative 7 raised to the 4th power is not the same as negative 7 raised to the 4th power. These are not equal to each other because this means negative 7 times itself 4 times. This means negative 1 times 7 times itself 4 times. These are not equal. So yes, that matters that you have the parentheses there. All right, number 9. I've got 3 things with the same base. 2 to the 4th, 2 to the 9th, and 2 to the 1st. So add all those exponents up. You get 2 to the 4 plus 9 plus 1, which is 2 to the 14th. So these ones here, 3 through 9 odd, are exponents that have the same base, and we're adding the powers. Now we've got number 11, and it is a base raised to a power, and that's being raised to a power. So if you remember from the notes that we just did, the rule is power to a power means multiply. 5 times 2 is 10. That's 3 to the 10th power. Piece of cake. What about number 13? Same thing. Once again, they have this in parentheses. That's fine. That means negative 5 times itself 3 times. And we're raising that to the 4th power. The rule is we take that base, we multiply the powers. Bam. Piece of cake. Number 15 is an example of a product. This is 15 times 29 raised to the 3rd power. So the rule is that we just take each of those numbers, 15 and 29, raise them to the 3rd power, and we would multiply those together. This is a good time for me to tell you we are not using a calculator for any of these. We are just simply leaving it with the exponents. That's it. Those are the directions. Those are the rules. If you use a calculator to do your assignment and you say 4 to the 8th power is whatever it is, 4,000 something, whatever it is, I will not be able to give you credit because this is all about the exponent rules. All right, moving on. Number 19. I skipped number 17 because it was like number 15. Number 19, oh my goodness. Now instead of having 4 to a power, I've got x to a power. No big deal, same thing. X to the 4th times x squared, same base, add the exponents. You get that base raised to the 6th power, 4 plus 2. What about this one here, number 21? Z squared, this is one of my pet peeves by the way. I hate when they put z's and 2's in the same problem. If you notice I put little lines for my z's. So we've got z squared, z to the 1st power, notice how they didn't put the 1 there, you have to put it there, and z to the 3rd power. That's going to equal z to the 2 plus 1 plus 3, which is z to the 6th. What about number 23? We've got a variable raised to a power, and that whole thing's being raised to a power. Power to a power, the rule is multiply. X to the 5 times 2 is x to the 10th. That's it. Number 25 is an interesting one. It's not like one of the easier problems we've done. It's got a quantity raised to a power, so sometimes people think that's a little confusing. But really, number 25 is the same thing as number 23. Instead of having x raised to a power, it's a parentheses or a quantity raised to a power. The rule is still the same. It's still that base, which just happens to be b minus 2, and then to the 2 times 6 power, which is b minus 2 to the 12th. Notice how you leave it in parentheses. Okay, number 27. Negative 5x. The first thing I want you to do is make sure that you put a multiplication sign between them, because negative 5x means negative 5 times x. Now we have a product raised to a power. That is just like number 15, where you had a product raised to a power. And the rule that we learned on the last worksheet was that we are going to take that number, raise it to the power, take the other number, raise it to a power. So, if I do that, I would have negative 5 raised to the second power times x raised to the second power. Now, this one I can simplify because I've got negative 5 squared, which is negative 5 times negative 5, which is 25x squared. They do ask you to simplify it, so I would go with that. All right? Number 29, same thing here. It's 7 times x times y. So what happens if I have 3 things squared? Well, you're just going to take each one of them and raise it to that power. What's 7 squared? 7 times 7 is 49. All right, now we get to numbers 31 through 49 odd, and these ones here, now we're combining things. So just do it one step at a time and be patient. This one is negative 10 times x to the 6th power. It's being squared. Then you're going to multiply by x squared. So first this becomes negative 10 squared, x to the 6th squared, and then x squared. So notice how I just did that rule, the product raised to a power first. Now I'm going to do negative 10 squared. Negative 10 times negative 10 is 100. X to the 6th squared, power to a power is multiply. That's x to the 12th. And then I've got x squared. Same base. What do I do with the exponents? I add them. So this is your final answer. So all of that ended up being this. Notice how I did it one step at a time. Please don't just go from here to an answer. If you do that, I can't accept it because clearly there's some work that needs to be done before that and you should show your steps. It doesn't take long. Number 33 is very similar to this. 6 times d squared times this parentheses raised to a power. So please excuse my dear Aunt Sally, I've got to do this exponent first over here. And if I want to do that, this is going to be 6 times d squared times 2 to the 4th power, product raised to a power, times d to the 5th raised to the 4th power. Now I've got some more work to do. I've got 6 times d squared times 2 to the 4th power is 2 times 2 times 2 times 2. 2 to the 4th power is 16. 2 times 2 times 2 times 2. 4 times 4 is 16. And then d to the 5th to the 4th power is d to the 20th power, because power to a power means multiply. Now I'm going to do 6 times 16, which is 96, and d squared times d to the 20th power, same base, add the exponents, boom. So these problems get a little bit lengthier, but not that much more challenging. Okay, so I've got 3 more problems here. They are multi-step problems. I put this one down here. This is the big kahuna. This one, the big kahuna in Hawaiian means like it shows mastery. Somebody who has like a profession, who's like a doctor or somebody like that. So if you can solve the big kahuna, then that means you have mastery of this section. Okay. So let's do number 35 first. Number 35 is negative, and then parentheses to the third power. So first thing I want to do is I want to put a 1 there, because this is negative 1 times that parentheses. So if I do that, I get negative 1 times 2 to the third power, p to the 4th to the third power, times, and then I've got negative 1.5 times p to the 7th. So now I've got negative 1 times 2 to the third power is 2 times 2 times 2, which is 8. P to the 4th power to the third power, multiply, because power to a power means multiply, times negative 1.5 times p to the 7th. So now I've got negative 1 times 8 is negative 8, times p to the 12th, p to the 7th is p to the 19th, because you add the exponents, times negative 1.5. Negative times negative is positive. 1.5 times 8 is 12, and you get 12p to the 19th. All right, we are almost there. I've got 2 more to do. 3x to the 5th to the 3rd is 3 to the 3rd power times x to the 5th to the 3rd power, times, and now I've got 2 times x to the 7th squared. That's 2 squared, and then x to the 7th squared. 3 to the 3rd power is 3 times 3 times 3, which is 27. X to the 5th to the 3rd power is x to the 15th. 2 squared is 4. X to the 7th squared is x to the 14th power. 27 times 4 is 108. X to the 15th times x to the 14th is x to the 29th. So that is that. All right. And last but not least, we've got the big kahuna. So if you've hung in there this far, hang in there for one more. If you'd like to pause the video and try it yourself, that's a good thing to do as well. So first of all, you've got negative 2 times s in the first parentheses. Then we're multiplying that to, I've got 4 things being multiplied here. Negative 5, r to the 3rd, s, and t. And it's all being cubed. So every one of those goes to the 3rd power. Now you're going to have negative 2, r to the 4th, s, t to the 7th, and that's being squared. So every one of those is going to be raised to the 2nd power. So negative 2 squared, r to the 4th squared, s squared, and t to the 7th squared. This is a lot of stuff. However, we're going to do this one at a time. Let's start by doing all of the numbers. We've got negative 2. We've got negative 5 to the 3rd power, which is negative 5 times negative 5 times negative 5, which is negative 125. Then we've got negative 2 squared, which is negative 2 times negative 2, which is 4. So that takes care of this, negative 2, the negative 5 to the 3rd power, and the negative 2 squared. Now let's do all the s's. So I've got s to the 3rd, so that's s to the 1st, s to the 3rd is, let me do this over here, s to the 1st, s to the 3rd, and I've got an s squared. So add the exponents and you get s to the 6th power. Now I've got an r to the third power, so I should multiply that. That's r to the 9th. Then I've got an r to the 4th squared. That's r to the 8th. And I'm not missing any other r's. That's it. So that would be r to the 17th. And last but not least, you've got t to the 3rd, and you've got t to the 7th squared, which would be t to the 14th. And we've got a t to the 3rd. So altogether, that's t to the 17th. Whew, the big kahuna. Negative times negative is positive. 2 times 125 is 250. Times 4, 250 times 4 is 1,000. S to the 6th, R to the 17th, T to the 17th. Thank goodness there was only one of those, right? So I hope you all have a good time doing your assignment because I went over every single type of problem. Obviously the easier ones I'd like everybody to make sure you know how to do, and then please don't give up on the challenging ones. Show your work. Keep in mind it's one step at a time. I always give the analogy, you can't eat a Big Mac in one bite. You got to take bite-sized pieces. I hope everybody's well. I hope you had a great spring break, and I'll talk to you tomorrow.